The quotient rule. The quotient rule is a rule we use to find the derivative when we have a function equal to some function divided by another function. And to find the derivative, we'll do numerator function times denominator function minus numerator function times denominator function. Take the derivative of the first and the derivative of the last. If we had made this a plus, notice the numerator would look just like the product rule. So it's very convenient to learn them in the same manner so that you could write the product rule and then change plus to minus for the quotient rule. And in addition, we're going to take the denominator function and square it. So when do we use the quotient rule? Well, we could use the quotient rule on any function that looks like this. Y equals numerator f of x divided by g of x. Y equals numerator over denominator f of x over g of x. Y equals numerator over denominator f of x over g of x. Y equals numerator over denominator f of x over g of x. Y equals numerator over denominator f of x over g of x. Y equals numerator over denominator f of x over g of x. Now, in some cases, it's up to you to figure out, is it easier for you to use the power rule? Which, remember, the power rule says if y is equal to ax to the n, then y prime is an x to the n minus 1. Sometimes it's easier to use that than to go through the whole process of using the quotient rule. For example, I would probably write this as 8x to the negative 3 and use the power rule. Here, I would probably divide the x into both terms of the numerator and write this as 3x to the negative 1 plus 1 and use the power rule on each of those. Here, of course, this is 6 over x to the 1/2, which is also written as 6x to the negative 1/2. I would probably do that and use the power rule there, but we certainly could use the quotient rule on all of these as well. If we're asked to find the derivative of this function, notice we have f of x over g of x. And here is our rule that we'll use. This is the quotient rule. If you recognize you have f of x over g of x, it's f dash of x g of x minus f of x times g dash of x over the denominator squared. So when we do this, recognize here that this top function, we can consider that f of x, and the bottom function, we can consider that g of x. So our derivative will be the derivative of the numerator, negative 1, using the power rule times the denominator minus 5 minus x, which is the numerator, times the derivative of the denominator over the denominator squared. So our derivative here will be negative 8x. If I distribute this 8 to both of them and then change the sign, so I'll have 40 with a minus 40, and negative 8x, and I change the sign, will give us positive 8x. So essentially, what I'm distributing to both of them is negative 8. And my denominator will be 8 times 8 is 64, x times x is x squared. So if I clean this up a little bit, we can see that the 8x cancels with the 8x. So our y prime will be negative 40 over 64x squared. These are both even numbers, so I can divide them both by 8. Not all even numbers like that. I was going to say that I can divide them by 2, but I'm going to get more greedy. 8 goes into 40, negative 5 times. 8 goes into 64, 8 times. So here is my derivative and our first example of the quotient rule. Notice this one says f of t. It's a function of t, but I'll consider this. I can still consider the numerator f of x and the denominator g of x to use our quotient rule, where the derivative is f dash of x g of x minus f of x g dash of x over the denominator g of x squared. So if I'm going to find this, I'll just call this f dash of t. I'm using the same rule even though my terminology is a little different. The derivative of the top is 1 times the derivative times the bottom, t squared minus 2t plus 4, minus the top, t plus 5, times the derivative of the bottom, using the power rule, 2t minus 2, all over the denominator, t squared plus minus 2t plus 4, sorry about that, minus this whole thing we're going to square that on the bottom. So, of course, I want to FOIL this, and I would get t times 2t is 2t squared. Outer is minus 2t, inner is plus 10t, and last is minus 10. So if I combine these two, 10t minus 2t is 8t. So look what I'm going to do. I have t squared plus 8t minus 10, and I've got to take the opposite of that. So if I have 1 distributing to our t squared minus 2t plus 4, I get t squared minus 2t plus 4. Now I'm going to take the opposite of, when I FOIL this out, I had 2t squared plus 8t minus 10. It's important to get these details right, otherwise the whole problem will be wrong. I'll probably just leave this term in the middle, just like this whole thing squared, a trinomial squared. I don't want to deal with that. Now look what I'll do. I'll distribute this negative to each and every term in the parentheses there to give us t squared minus 2t plus 4, careful, minus 2t squared minus 8t plus 10, and that's all over a denominator of t squared minus 2t plus 4, the whole thing squared, which gives us, well, can I cancel anything? I have t squared minus 2t squared, which is negative t squared. I've got negative 2t minus 8t, which is minus 10t, and I've got 4 plus 10, which is 14, all over t squared minus 2t plus 4, the whole thing squared. So this last one here, that is my derivative. Even though it took a lot of work, we did get there. Here's our first instance where we're going to use the quotient rule. Remember, the quotient rule is if y is f of x over g of x, then the derivative is f dash of x g of x minus f of x g dash of x over g of x squared. So I'm going to recognize that this top function, I'm going to call it f of x, and this bottom function, I'm going to call it g of x. So y prime is equal to the derivative of the top, which is 7 times the bottom function, minus 7x minus 2, which is f of x times the derivative of the bottom function, divided by the function in the denominator, the whole thing squared. So I can write this as, well, of course I'm going to distribute and distribute to get 35x plus 21. Now I'm going to actually distribute, I'm going to combine the negative and the 5 to distribute to both. So it's really like this. I'm going to change the sign of both. 5 times 7 is 35x. If I distribute that negative 1, I get negative 35x. And 5 times 2 is 10. That's a negative 10. Distribute the negative, I'll get a plus there, all divided by 5x plus 3 squared. Now you certainly can FOIL that if you want to. I'm just going to leave it in factored form, because if I leave it in factored form, maybe I can cancel something. 35x cancels with negative 35x, and plus 21 plus 10 gives me 31 over 5x plus 3 squared. I couldn't cancel anything, but that's a fine answer there.